Good morning to all. Today we're going to see about the geometric modeling in the subject CAD/CAM and automation, where the three types of major geometric modelings are available. It is called wireframe modeling, and then surface modeling, and the solid modeling. These three are very important in the geometric modeling techniques, where wireframe modeling is nothing but where the nodes and edges will be considered. Surface modeling is based that at top of the or bottom of the side of the model to be considered. Solid is a whole cube or sphere or whatever the model will be considered for the modeling. Wireframe modeling. Wireframe modeling uses the points and curves. As I told, the lines, circles, arcs to define the objects. We can see here that these points and these node edges are the wireframe modeling technique. We call it as line, circle, arcs to define the objects. Uses edges and vertices. This is the vertices and this is an edges. This is called wireframe modeling. Example is 3D object. Surface model, where surface model represents the skin of an object. These skins have no thickness or material type. Whatever the, for example, you take the chalk piece box where front top of the model, we call it as the surface model. So the here will not consider any the thickness or material type. We in the manufacturing process many the surface finish to be considered. Here we use the like surface roughness testing machines also to make the surface in a fine path. Surface modeling is more sophisticated than the wireframe modeling in that it defines not only the edges but also the surfaces. Where in case of a surface modeling, the objects are defined by their bounding faces. As you seen the last next image, the surface entities will be considered the analytical entities and also the synthetic entities. Where analytical entities are the plane surface, ruled surface, surface of revolutions, and tabulated cylinder. Also, we consider for the surface roughness, synthetic hairpin, B-spline, Bezier curves, and Bezier surface, Kunz patches. These are all be considered. Plane surface. This is of an example of the surface modeling technique. Surface of revolution. This is an axiometric design. It is generated by the rotating a planar wireframe entity in the space about the axis of symmetry as a certain angle. Next one, the solid modeling. The solid modeling is one of the major and important concept we are doing in the mechanical engineering software, where it is used to define the vertices like nodes, edges, surfaces, weight, and volume. The model is a complete and unambiguous representations of precisely enclosed and filled volume. This is very important in solid modeling, where this model will be do it in the design software, and some of the models already available to assemble as an assembled product in the software. Methods of creating solid model. CSG, we call it as is a separate topic we'll discuss on another class. Constructive solid modeling. There is some of the CAD packages we use. This CSG is the Unigraphics, AutoCAD, 3D Modeler, Solid Edge, SolidWorks. These are some of the software regularly we using this boundary representation. Many design softwares have been now developed to make these kind of solid models. It is very useful to all kind of automotive sector and the medical and architecture, electronics. In many places, the solid model technique will be used. Primitive solids, where the primitive solid functions as a solid of simple shape from among the primitive solids stored in the program in advance. These are some of the cylinder, block, sphere, wedge, torus, which are all some of the solids which have been available in the tools, I mean the software. We can retrieve whenever we require to make it in the design. Constructive solid geometry defines the model in terms of combining basic and generated. It is using for executions and sweeping operations, where this constructive solid geometry is the term we can use for the basically available primitive function. It is used for the extrusion purpose. Also, we can use these Boolean operations to AND gate, NAND gate, or some other Boolean operations to make this kind of CSG. Like as I told, the union, we can for the unite joining the two volumes included in the different solids. into a single cell. The operation combines two volumes included in different solids. Subtract where cut one part from the one solid. Where intersection is nothing but uh, the operations gives only the volume common to both the solids, where the common basis has been intersected easily to join the CSG. Boolean operations, NAND gate, A union B, subtract, and then intersection. These are all about the geometric modeling techniques as we discussed: wireframe modeling, surface modeling, and solid modeling. We'll discuss about the CSG in a separate class next. Thank you.